In this video, we'll take a brief look at relational database tables and their characteristics. The logical view of the relational database is facilitated by the creation of data relationships based on a logical construct known as a relation. Because a relation is a mathematical construct, most users find it much easier to think of a relation as a table. A sample table representation that will be used to illustrate relational table characteristics is shown here. You will discover that once you understand the requirements of a relational table, it is possible to spot and define some entity relationships using a table view of the data. Relational tables are two-dimensional, meaning that they are composed of rows and columns. Each table row, also called a tuple, represents a single entity occurrence within the entity set. For example, student number 324273 is a single entity and has many attributes associated with it, such as first name, date of birth, and GPA. Each student is represented by a single row, and each row contains data on a single student. Each table column represents an attribute, and each column has a distinct name. In this example, the seventh column represents the student classification for each student and is named Stu Class. No other column in the table can have that exact same column name. Each intersection of a row and column represents a single data value. For example, this student's classification is SR, or Senior. All values in a column must conform to the same data format. For example, all attributes in the student date of birth column are dates. Each column has a specific range of values known as the attribute domain. For example, all attributes in the student GPA column are numbers between 0 and 4 with 2 decimal places. The order of the rows and columns is immaterial to the DBMS. Each table must have an attribute or combination of attributes that uniquely identifies each row. In this example, the attribute student number uniquely identifies each row because all values are unique. That is, there are no duplicated values. It is important to understand that a table is actually a logical concept rather than a physical construct. The data is not physically stored in this format. One of the great advances of the relational model, however, is that we do not have to work with the data as it is physically stored. We only interact with the data as if it were in a table structure. Be aware that many database software vendors still refer to table rows as records and table columns as fields because this terminology is familiar in most programming environments. This concludes our presentation.